Myself, Dr. Niranjan R.S., Assistant Professor, Department of Physics, Government First Grade College for Women, Palaneshipura. Now I am going to discuss the quantum confinement in one dimension, which comes under the unit nanoscale systems. Quantum confinement in one dimension means in nanowires, carriers are confined in both y and z directions and allowed to move freely along the length of the x axis. The examples for this are zinc oxide nanowires, gallium trioxide nanobelts. These are the examples for this. In this case, the electrons are the charge carriers, holes or electrons, which are allowed to move freely along the length of the x-axis, and they are confined in both y and z directions and allowed to move freely along the length of the x-axis. This figure represents the one-dimensional nanowire. Particles are only allowed to move freely along the x-axis and confined along y and z directions by a distance small t, assuming square cross-section. In the case of nanowires, if we solve the Schrödinger wave equation, we get the wave function and also we can get the energy eigenvalues by considering the particle trapped in a one dimension and solving the Schrödinger wave equation, we get the wave function. The obtained wave function is 2 by t sine of n xyz equals 2 by t sine of nz pi y by t sine of nz pi z by t e to the power of I kx x. This is the wave function. This wave function gives the values, that is the corresponding energy values can also obtained by solving the Schrödinger wave equation. The energy corresponding to these wave equations is En equals h square over 8md square ny square plus nz square plus h square kx square over 2m. These are, if we substitute the values for n equals 0, 1, 2, 3, etc., we get ground state energy levels, first, second and third state, etc., higher energy levels, and substitute the value of n in the wave equation also, we get the wave equation for the ground state, first and second and third, etc., energy levels, wave equations also we get. In nanophysics, motion of charge carriers in carbon nanotubes or similar kind of nanowires can qualitatively be treated by the above equations. Although the actual bond states and the energy expressions are more involved and more complicated. This is the information we obtained from the references which are mentioned here. Thank you.